So this one says that using a dot, question number 1, using a dot and cross diagrams, show the structures of the following compounds. So magnesium oxide, so they says show outer shells only. So they want us to show outer shells only. So we can put up a key because they have told us to use dot and cross. So I can simply say, you know, let the dots represent electrons of oxygen, and the cross represent electrons of magnesium. That's what we mean. So remember, magnesium and oxygen forms an ionic bond, so we just want to show the outermost shell. So let's go quickly and write the electronic configuration. Proton number is 12, so EC is 2,8,2. Then when it comes to oxygen 8 there, the EC is simply 2,6. So if you notice, oxygen needs 2 electrons to have 8 electrons in the outermost shell, but the magnesium will give the 2 electrons there to the oxygen so that it becomes you know, stable. So since they just want us to show the structures of the following compounds, so what I'm going to do is that you know, I'll draw you know, magnesium. So if this is magnesium now, so it will remain, when it gives out the 2, it will remain with the 8 electrons in the outermost shell. But we enclose this you know, in the square brackets because it has lost 2 electrons, so we give it a 2 positive charge there. Then on the other hand, you notice that the oxygen atom there, it had how many electrons? It had actually 6 electrons in the outermost shell, but it has gained 2. So therefore enclose it in bracket as well and give it a 2 minus because it is gaining 2 electrons. So that is a type of bonding we call as being magnesium oxide. Hopefully that helps you out. What about carbon dioxide? It says show all the shells. So they want you to show all the shells. So again, we can simply use the keys. The key in this case, I'll simply say the cross will represent electrons of oxygen and the dots will represent electrons of carbon. Again, we write the electronic configuration. If you notice, for oxygen, like we said, it is simply 2,6, but for carbon, which has got you know, 6 there, the electronic configuration will be 2,4. Now these are both non-metals. This was between a metal and a non-metal. No wonder this type of bond was simply an ionic bond. But in here, you know, carbon dioxide is simply CO2. There are 2 oxygen that have been attached when you write your formula. This is simply a covalent bond existing between non-metals. Therefore, if you look at it, the one that requires the most number of bonds between oxygen and carbon is which one? Is carbon. So we put the carbon right in the center. So remember, they told us to show all the bonds. So for carbon, I'm using the dots that's in the first shell. Then in the second shell, that's what is going to happen. So now the oxygen will now be attached to the carbon. So the carbon, and that's the oxygen. So we are going to show the inner. So this is the oxygen. We are going to show that's the oxygen. So it has got 2 electrons in the innermost shell. Remember, the one that requires the most number of bonds, put it in the middle, then these others will attach to that middle one. So in this case, because oxygen, for it to be stable, needs 2 electrons to have 8, so it will contribute 2. The oxygen will put up 2, and the carbon will put up 2. The oxygen will put up 2, and the carbon will put up 2. So remember, the carbon had only 4, so it has shared all that it had. But oxygen out of the 6 has only contributed 2, so it is remaining with the 4. 1, 2, 3, 4. Even this side, 1, 2, 3, 4. And this is simply the bonding in carbon dioxide. That is what they wanted you to do there. Then it says state any 2 differences in physical properties between ionic or electrovalent and covalent compounds. So they are simply talking about in terms of, you know, physical in terms of physical properties. So I can simply say that ionic, compounds, have a high melting and boiling point compared to covalent compounds. So that's one of the physical properties that I can talk about. Then the other physical property that I can simply talk about is that